Okay, so here we're looking at a 1 over, or x approaches 0 from just the positive side of cotangent x minus 1 over x. Now, cotangent is cosine over sine. So as you're approaching 0 from the positive direction, cosine is approaching 1, sine is approaching 0. It's only 1 over 0. That's going to be infinity, positive infinity. And as x goes to 0 from the positive direction, of course 1 over x is going to be approaching 1 over 0, which will be infinity. So we once again here have an infinity minus infinity limit. Now in this example here, really not something nice that you can factor out. You actually can try this by factoring out a 1 over x, but then that kind of makes things a little messy as well. A little bit messy as well, factoring out a 1 over x. You could try it, but things actually get kind of messy there. So instead, I recognize that cotangent is a fraction. Right? Cotangent is a fraction. Specifically, it's a fraction involving sine and cosine. So what I'm going to do is first rewrite that as a fraction, cosine x over sine x minus 1 over x. Say to myself, hey, why don't I try to put these fractions together? It is definitely an infinity minus infinity limit right now. But let's try to put the fractions together. Since I have fractions, let's put them together. I didn't have fractions here. If I had some fraction stuff here, maybe I'd try to put those together. The hope being that once it becomes a fraction, then I either would have maybe a 0 over 0 or an infinity over infinity limit once stuff's written as a fraction up there. Once we put the things together, it'll be a single fraction, which would hopefully then be of a different indeterminate form, either 0 over 0 or infinity over infinity. So that's kind of the idea there that we're looking at. So we want to get a common denominator. So we can do that. Limit as x approaches 0 from above 0. Common denominator for sine x and x would just be x sine x. Okay. So to build those new fractions, I would need an x to go with the cosine. And for the 1 over x, I would need a sine x there. Okay. So then we check the new thing that we have here. Okay. It's no longer an infinity minus infinity issue. Because now if you look at it, as x goes to 0, this will be 0 times 1, which would be 0. Minus 0, so the top is 0. In the bottom you have 0 times 0, which would also be 0. So we've transformed this into a 0 over 0 limit. Okay, and now we can invoke L'Hopital's rule once again. So the goal in these problems, when it's some other indeterminate form, is we want to transform the way it looks. Very often, a common way of doing that is to factor out a common factor that lends itself. The other option that we look for is to try and, if we have fractions, let's put them together into one fraction. Can we combine things into a single fraction? Okay. Hoping again that when it's written that way, that we'll have, are hoping that when it's written that way, we'll now have something again that we can work with. Okay. And so here we have a 0 over 0, so we use L'Hopital's rule and take the derivative. So limit as x approaches 0 from above of the derivative of x cosine x. Well, x times cosine would be x times the derivative of cosine, which would be minus sine, so we'd have minus x sine x. And then we'd have cosine times the derivative of x, which would be 1, so it would be plus cosine. and then minus the derivative of sine, which happens to be cosine. So things are looking kind of good up top because we get rid of those two cosines. They leave the problem. And then in the bottom, I have just the derivative of x sine x. So that'll be x times the derivative of sine would be x cosine x plus x sine times the derivative of x plus sine x. So where am I at now? Well, limit as x approaches 0 from the positive direction of negative x sine x on top over x cosine x plus sine x. Unfortunately, right now, we're still faced with a 0 over 0 limit. Right? On the top, x is going to be 0, sine is going to be 0, 0 times 0 is 0. On the bottom, 0 times 1 is 0, plus 0. So we are still dealing with another 0 over 0 limit. We apply L'Hopital's rule a second time, hoping that will get us there, make some kind of progress. So limit x approaches 0, positive direction, the derivative of negative x sine, so that would be negative x cosine x, plus sine times the derivative of negative x would be minus sine x. Okay, that's still going to 0, which kind of leaves us a little discouraged. Then we do the derivative of x cosine x. X cosine x will be x times the derivative of cosine. That will be minus x times sine x plus cosine x times the derivative of x, cosine x, plus the derivative of sine, which would be another cosine. And now finally, we have what we need. This is still 0. Right? 0 times 1 is still 0. That's still 0. That's still 0. But these two things aren't. And this time they're not being subtracted, they're being added. And so, therefore, this thing can now be computed. It's no longer a 0 over 0 limit. It's a 0 over 2 limit, which means this whole thing just goes to 0. This whole thing just goes to 0. Okay, and so now we have it. Like I said, you could try this problem with factoring out a 1 over x. That would give you 1 over x times x cotangent x minus 1. Right? And that would give you an infinity times a 0 times infinity minus 1 limit. So you actually get a 0 times infinity limit, so you would have to work that limit out. You would have to actually work that out. And then once you figured out that, you can then combine that with the infinity and then work the problem out. Okay. Work the problem out. What you would actually find is that this actually, infinity times 0 actually approaches 1. So it's actually 1 minus 0. Actually 1 minus 0. And then you would have to put that back together with the other infinity and have an infinity times 0. And you'd have another one to work out. So that's something you can kind of start playing around with if you wanted to. But this way is actually more efficient. Because we have fractions, let's put those fractions together. Not having fractions, then our hope is that we can find something we can factor out. Something we can factor out that can let us make progress with the limit. Okay, so those are infinity minus infinity limits, and those are again are the more difficult ones to deal with.